All right, this is lesson 7.5. We're going to learn how to solve a polynomial equation if it is already factored. Take a moment to write down the big idea notes. All right, so let's go over the big idea. Um, First, you need to know what it means to be in a factored form. And that all that means is that we take a polynomial and we write it as a product of factors. So for instance, here is a polynomial, x squared plus 2x. And if I want to write it in factored form, I'm going to need to do some factoring on it. And so kind of think of like what that means. Let me just write a numerical example. You don't have to write this in your notes if you don't want. But let's say if I take the number 15 and I say, what's its factored form? That would mean I'd write it as a product of two numbers, like 3 times 5. Okay? I could do other things as well. I could take, let's see, how would I write 14 as a product? Well, that's a couple ways. I could do 2 times 7. I could also do 2 times 3 plus 4, right? Because 7 is the same as 3 plus 4. So this would be another way to write that. Where does that come from? So another thing to think about is that if I wrote 14 as 6 plus 8, I could write this in a factored form by taking a common factor from 6 and 8, which is 2, and then divide out that factor, and that would give me the 3 here, and divide this by 2, and that would give me the 4, so plus 4. In other words, I'm sort of doing the distributive property in reverse. I'm thinking of the common factor that multiplied the inner terms, and then rewriting it using that. That's what we do with factoring polynomial expressions. We look for a common factor and we take that out and then rewrite it using distributive property. So for instance, this one has a common factor of x in each term. So if I took that out, I have to, and then what would I multiply to get this back? What would go inside the parentheses? Well, this is x squared, and x squared is x times x, so that means I need a factor of x times x squared. This is 2 times x, so the x is here. What needs to go in here? The 2. So we put plus 2. And then if you multiply this back out, x times x squared, x times 2, 2x, the sum, then you get back the original polynomial. So that's called factoring. And I'm using the distributive property in reverse to do it. So taking out a common factor. Another way to do it, which is what we're going to learn in the next unit, but I'll just show it to you, is that this polynomial can also be factored, and it comes from the following factors. I take x plus 8 and x minus 3, and if I multiply those together, I get this. Can you kind of see it? You know, x times x is x squared. If I multiply the 8 times negative 3, I get negative 24. And where does the 5x come from? Well, it comes from the two other multiplications that we're going to do, 8x and negative 3x. Those together give me positive 5x. So this is the factored form of that polynomial. Well, we're going to give this to you today. We're not teaching you how to do the factoring. I just wanted you to recognize that we can rewrite a lot of polynomials in this kind of form. All right, so here's the property we're going to use to do solving equations. It's called the zero product property. And what it says is that if I multiply two things together that are set equal to 0, so you've got to have this 0 here for this to work. And that's why it's called the zero product property. We have a product of two things that are equal to 0. All right, if that happens, then one of them has to be 0 themselves. Like A could be 0 or B could be 0. So what that means is this. If I write 3 times something equals 0, what has to go in that box? What number could possibly, can't be 1. 3 times 1 is 3, right? So what number goes in there? Should be guessing 0. So that's what we're saying here, is that one of these two factors has to be equal to 0. And this is the key to solving a factored form. And I'll show you how it works. So here's my first my first equation that I have to solve. And so I have a product. This is x times the quantity x plus 8, and it's set equal to 0. So in the zero product property, it says if you have two things multiplying to 0, one of them has to be 0. So my first thing is the x. So maybe x is 0. So I write that. X could be equal to 0. The other thing is my second factor, which is a sum this time. It's a quantity, x plus 8. That could be equal to 0. So I write x plus 8 equals 0. Now this one doesn't need any solving. It's complete, and it's saying that x could be the value of 0. This one we need to do a little work on. So I'm going to subtract 8 from both sides. And then solve. And I get x equals negative 8. So I have now two values for x that should make this true. If I plug in 0, let's see what happens. So when x is 0, I plug in 0 to the original problem. I get 0 times 0 plus 8. Okay, let's simplify that out. So that's 0 times 8, and that's equal to 0. Check. Now I try the second value, negative 8. All right, so negative 8 goes in. You don't plug them both in at the same time. It's one at a time. So negative 8 goes in. So negative 8 times negative 8 plus 8. Wherever the x was, I plugged in negative 8. Now let me calculate that. All right, the first part is negative 8. This quantity is 0. And negative 8 times 0 is 0. Check. All right, so my two solutions are x equals 0 or x is equal to negative 8. All right, so here is a factored form. My first factor is x plus 6. My second factor is x minus 7. One of those two factors has to be equal to 0 for this equation to be true. So I write x plus 6 is equal to 0, or x minus 5 is equal to 0. And then I solve those. All right, the first one, we would need to subtract 6 to solve it. And that would give me x equals negative 6. Second one, I would need to add 5 to solve it. You solve each of these separately, two different equations. All right, and the result of that is x is equal to 5. All right, let's do a check step. All right, what if x is negative 6? Let's plug it in. X equals negative 6. And let's see what happens. All right, negative 6 goes in here and in here. So negative 6 plus 6, and then negative 6 minus 5. All right, this part right here is 0. 0 times negative 11. Well, that product is 0. Check. Let's check the second one. X equals 5. Plug in the 5 in each of these two spots. 5 plus 6 for the first term, and then 5 minus 5 for the second. The first term is positive 11. The second one is 0, which is equal to, that product equals 0. Check. All right, so you can kind of see what happens is that we get two solutions because in each case we're making one of the factors go to 0 at a time. And no matter which one is 0, we get the solution of 0 at the end. Okay, so we have two solutions that make this true. All right, so I won't be doing the check step with the following ones, but I just wanted to illustrate that idea. Now, by the way, just as a note, we do call these solutions are sometimes referred to as roots or zeros. I may occasionally throw out those words when we do solving, so keep that in mind. They're called roots or zeros. Maybe the zeros will be easy to remember because we're trying to get it to be equal to 0. The roots come more from when we do graphing of these equations. but they're all referring to the same thing. All right, so let's just practice solving a little bit. Okay, this is factored form. And so we have 3x is our first factor. So that could be equal to 0. And the second factor is the quantity. So 2x minus 1. And we set that equal to 0. And then we solve each one separately. So divide by 3 on both sides for the first equation. And this results in 1x equals, and 0 divided by 3 is 0. So x could be 0. And that makes sense. 3 times 0 is 0. All right, solving this one, we'll add 1 to both sides. And that gives us 2x equals 1. I'm going to divide by 2 on both sides. And that gives me x equals a half. All right, whoops, make sure you can see that. My solution is x could be 0 or x could be a half, and I box them both. All right, now this one. This is a quantity squared. A couple ways to think of this. But first I'm just going to write it in expanded form, just so that you recognize the factoring. Oh, and it's not an equation, by the way. So that we're not solving unless we have an equation. So let me add that back in. So we have this quantity equal to 0. You do want to recognize that this is really just w minus 4 times w minus 4 equals 0. I'm not really going to solve 2 of these. These are the same. So I only really need to solve 1 of them. All right, so that would mean that w minus 4 is equal to 0. And I get, when I solve this, add 4 to both sides. And that gives me w equals 4. All right, that is a single root. However, it is often called a double root because it comes from the same factor, two of the same factor. So it's a double root. Oh, single solution, double root. There's that word root, right? I told you I was going to use it. All right, could you solve these using mental math? So have you seen any patterns here when we're solving? So for instance, if we go back up to this first one, we had x plus 6 as a factor, but the solution was x equals negative 6, right? And this one was x minus 5, but the solution was x equals 5. Do you see an opposite pattern happening here? Plus 6, and the answer is minus 6, minus 5, positive 5. Well, so hopefully you get faster at solving, you start to see some patterns, right? Well, so looking at this, can you think of opposites? This would be, solution could be, I'm going to put it down here so we can actually solve it and check it. But I think the solution should be negative 2. Should be negative 2. And w minus 7, the solution should be equals 7. And so if I just quickly solve that, w plus 2 equals 0, subtract 2 from both sides, you get y equals negative 2. So that's exactly what I thought it would be, and the same thing will happen with this. Now you can't be careful, because if my polynomial has a coefficient, you have to do that's 2 steps there. So mental math, could you have come up with a half? So be careful about something like this. But when we have a coefficient of 1, it can be pretty easy. How about this one? Mental math? It's a double root again. So k plus 1, I'm really just solving k plus 1 equals 0. What is that with mental math? K would have to be the opposite of 1, which is negative 1. And that's our lesson. It's time for you to practice. Go to section 7.5 and get going. All right?